Welcome in. All right, so finally, okay, so here is the introduction to electrical energy and power. So everything to do with electricity. I was looking forward to talking about this particular unit. So what is electrical energy, and then how does it relate back to power? So first off, so electricity, whenever you're utilizing that term, it means it is the flow of these tiny particles, which we call electrons. By the time that you get into physics and into this point, you've heard a lot about electrons, in particular in science and in chemistry. So it won't be too far off in terms of understanding this. But the key thing is, it is the flow. So it is the flow of these electrons that we have through a conductor. Now, you may remember the words conductor and insulator, okay, in terms of thermal energies and then heat transfers. So a conductor of thermal energy meant that you can transfer heat very easily through those materials. Well, in this case, and very often it's very similar, you can actually allow electrons to flow very easily through certain materials. And again, they're called conductors, just electrical conductors instead of thermal conductors. And insulators mean the opposite. So they are insulating, and therefore thermal energy didn't flow very easily. So heat didn't transfer through insulators very easily. And the same thing happens here. So electrical insulators, you just simply can't allow electrons to flow very easily through these insulators. So when you're talking about electricity and the flow of these electrons, it is through a conductor. And that particular conductor can be any material that just simply allows those electrons to flow. So that is electricity, and when you hear that particular word. Now, these electrons carry energy. Well, they are in movement. They are kind of moving along from one place to another. When they're going to be moving along, because of the fact that they're electrons, we call that electrical energy. Now, electrical energy is just one form of many energies that you have already studied. You had mechanical energy in terms of kinetic, potential, gravitational potential energy, thermal energies, etc. I'll put up a link up above there. It is worth taking a look to remind yourself of all the different forms that energy can take on. So when you're talking about electrical energy, it is very specific to the concept of electrons and the flow of those electrons. Now, as they are moving, when you take those electrons, that movement is called an electric current. You're going to run into this word as well. So that current is the flow of the electrons. That's what you have there. And so here, the electrical energy is, again, the flow of these electrons that you have, and they carry the energy along with them. And then if they are flowing, and we notice that we have quite a few of these electrons that are flowing by, it is the electric current that we call it. Instead of saying flow of electrons, we say current. Now, lastly, as we have electrons and they are moving in here, so again, the movement is the concept of kinetic energy. So that particular electrical energy, as it is moving along, the electrons themselves bump and collide with various atoms and molecules in the material as they're going through. Therefore, they're transferring their energy. They have the ability to do work. So through these conductors, like a wire, the electrons can transfer that energy as they're going through all the way along. And they can be bumping along other molecules and atoms, and they're carrying that energy all the way through. And therefore, they can do work, or they can transfer into other forms of energy. Very often, thermal energy, because heat gets anticipated due to all the friction and the bumping along of those electrons. So there you have it. So now you know what electricity is. It's the flow of these tiny particles called electrons. So that's one. That flow of those electrons we typically call current, electric current. Those particular electrons carry energy due to their motion throughout, and as they bump along, that energy is called electrical energy. And that's what we have. Lastly, as you are moving the energy themselves, so as energy moves over time, please remember that that is nothing else but power. And I'll put up a link up above there. So you've been introduced to power way back when you were discussing and talking about energy, just different forms of energy. Jump into electrical energy, but we're going to need to talk about power. So power is going to be the flow of the actual energy over a certain amount of time. And if you want to know what the total change of energy is, and someone gives you what the power is, then you can take the power, multiply it by the change in time, and you're going to get how much energy it carries. Deja vu, in terms of the energy units, you were very often used to joules and kilojoules way back, but now we're going to start talking about, because it's much more convenient, joules are too small, we're going to start talking about kilowatt hours, and that is a unit of energy. Now, very often people confuse this unit and they think it's power because they see watts. And it is correct that power, the metric standard unit, is indeed watts, which is nothing else but joules per second. However, kilowatt hours is not power, it is energy. And if you want to know why, I'll put up a link up above there to an extremely short video that discusses kilowatt hours. So that is it in this introductory chapter, okay, and the start of talking about electricity and then moving on to magnetism. All right, happy learning, everybody. See you soon. Bye, everyone.